Here's a problem you may like. It's about laptop computers. So they generate a lot of power. So then, diagram's kind of interesting for this. There's a specialized diagram which we're going to use, and the diagram is actually an electrical circuit diagram. It's a schematic, as they often call it in the trade. And it says that if you make a drawing of this type, you need to have symbols for the various things. That's a battery symbol, and here's a resistor. These lines stand for perfect conductors. Wires are pretty good, almost perfect, close enough. And here's what it says. It says that there's a 16-volt battery that's powering this whole thing, and it says also that the current that is generated, that flows through this wire, I, is 1.5 amps. So 1.5 amps worth of charge flow. Fine, that's all good. So then, what is it that the problem wants to know here? It says how much power is dissipated. So we need a physics principle. Physics principle says that power is I times the voltage. Well, that looks pretty easy, doesn't it? Because we know both I and V. So then, this must be 1.5 amps multiplied by 16 volts. And 1.5 times 16, that's probably about 24 in numbers, and it's watts in terms of power. And so this is 24 watts. That's what the laptop generates. There must be a B part to this problem. That must be the A. The B part to the problem says, since this is the resistance that the computer is offering to the flow of charge, then let's find out what the R is. So what do we have for that? Well, we know that V equals IR, and that is Coulomb's law. Sorry, Ohm's law. We use Coulomb's law in another problem. That's Ohm's law. So then Ohm's law says, if we want to find R from this, here's the way we can do it. R equals V over I. Be right with you. And so that must be 16 volts divided by 1.5 amps. And so what's that all together? It looks to me like, wait a minute, I didn't ask for a B part. How did that happen? So, well, who makes up these problems anyway? There isn't any B part to this problem, there's only an A. Well, I guess if you finally did it, you'd find out that this is 10.7 ohms. So just in case somebody makes up a B part to this problem and asks it later, now you know what it is. There you go.